Let's kick things off with a pretty wild idea, something that feels like it's pulled straight from science fiction.
So what if an AI could build a game world around you as you played? It sounds nuts, right? But this is exactly where we're headed. We're not talking about some pre-built map you just explore. We're talking about a world that is literally born from your every move, your every decision.
I mean, just imagine a world that doesn't just exist. It's being created and evolving in real time based on what you do. A world that adapts, that remembers where you've been, what you've seen. One that feels genuinely alive because it's being generated completely on the fly.
So this whole idea isn't just some sci-fi fantasy. It's actually the core concept behind something AI researchers call world models.
Okay, so what is a world model? Well, you can think of it as an AI that builds a little simulation of reality inside its own mind. It learns all the rules, the physics, cause and effect, the basic logic of a place, so it can predict what's supposed to happen next when you do something.
Now, the dream here is a world that's perfectly interactive and persistent, but the current reality? Not so much. We're running into some major hurdles. We want that instant, real-time feel, but what we get is slow, laggy generation. We want a world that has a long-term memory, but right now, these models tend to forget important details. And we need a world that's spatially consistent, but instead, things get weird, scenes start to drift, and just stop making sense. And this is exactly the problem that a new system called Matrix Game 3.0 is designed to tackle head-on. It's a really serious attempt to finally bridge that gap between the dream we all want and the reality we currently have.
You can think of this system like a high-tech factory, broken down into 3 main stages, all working together to build these amazing worlds. First, you've got the data engine. Then, that feeds into the model training pipeline. And finally, it all ends up at inference deployment, which is what makes the whole thing run in real time.
So let's start at the beginning. The foundation for all of this, it's data, a truly mind-boggling amount of data.
And here's the crucial thing to remember. An AI can't just create a world out of thin air. It can't build what it's never seen. To simulate a world, it first has to understand what a world even looks like, how things behave, how actions lead to reactions. And for that, you need a massive, super diverse library of examples.
And this is where the data engine for Matrix Game 3.0 gets really clever. It combines 3 totally different sources. First, you have these perfect cinema-quality scenes built from scratch in Unreal Engine 5. Then you've got tons of automated recordings from huge AAA games like Cyberpunk 2077 and Red Dead Redemption 2. And finally, they mix in real-world video, footage from city driving, aerial drone shots, all kinds of stuff.
And this is such a smart approach, right? Because on one hand, you get this perfectly clean, controllable data from the game engines. But on the other hand, you get the messy, chaotic, unpredictable nature of real life. By mixing them together, you're giving the AI this incredibly rich, well-rounded education on how worlds are really supposed to work. Okay, so you fed the beast all this data. Now comes the next huge challenge, building a model that can actually remember everything consistently. I mean, what good is a world if it forgets what you did just a minute ago, right?
Yeah, the biggest problem for these AI worlds is a technical thing called error accumulation. But here's an easy way to think about it. Imagine you're drawing a map from memory. With every new street you add, you kind of forget the exact placement of the first few streets. Over time, all those tiny little mistakes build up, and your map becomes a total mess. That's exactly what happens to these AI worlds. They just drift and stop making sense. So the solution they came up with is pretty genius. The model uses something called an error buffer. Get this, it actually learns from its own mistakes. So instead of only training on perfect, clean data, it's also shown the glitchy, imperfect frames it creates itself. This forces it to learn how to self-correct.
Yeah, this whole error-aware training thing teaches the model to fix its own work on the fly. It learns to spot when things are starting to go off the rails and adjust, kind of like an artist who keeps stepping back from the canvas to make sure the whole painting still works together. And because of this, the model can keep the world coherent and stable for way, way longer.
Okay, so we have a world with a great memory, but that perfect memory is totally useless if the world moves at a snail's pace. For it to feel real, it has to be real time, and that is the final crucial piece of the puzzle. And here's the magic number, 40 frames per second. That's the speed they achieved. For those of you who are gamers, you know that's the sweet spot. That's what you need for truly smooth, real-time interaction. It's the difference between a clunky, laggy tech demo and an experience that feels totally fluid and immersive.
So how in the world do they get that kind of speed? Well, they use this really clever technique called distillation. The best way to think about it is like this. You have a huge, super smart teacher model. It's slow, but it knows everything. This teacher then trains a smaller, much faster student model. It basically passes down only the essential knowledge, teaching the student just enough to get the job done quickly and efficiently.
And that's not all. On top of that, they use a bunch of other optimization tricks to make the final model as lean and mean as possible. It's kind of like compressing a giant video file so it's faster to download, but you don't lose any of the quality. They're basically slimming the whole thing down so it can run at maximum speed.
All right, so let's pull this all together. We have a massive data factory, a model that has a self-correcting memory and real-time speed. So, what's the big deal? Why does any of this actually matter? Well, this technology is so much bigger than just video games. It is paving the way for a future filled with these incredibly dynamic, intelligent, interactive experiences. We're talking about games where the world literally builds itself around you as you play, or powerful simulators where we can train robots for really complex real-world jobs. And of course, this is a huge step toward truly immersive and persistent virtual and augmented realities, the whole XR future.
And that really leaves us with a big final thought. This isn't just about making cooler video games. It's about creating an entirely new way to interact with digital information. So, when our virtual worlds can finally remember and react with the same persistence as the real world around us, what kind of new realities are we going to create?